Here's our problem. We have a semicircle containing two equilateral triangles. The large triangle sits with its base on the diameter and its apex touching the arc. The small triangle points downward, with its apex at the large triangle's right corner. We're told the small triangle has area 3. We need to find the area of the large triangle. Let's call the side length of the large triangle A and the side length of the small triangle B. Our strategy is to find the relationship between A and B using the circle. Let's mark the center of the semicircle as point O and point P at the right vertex of the large triangle where both triangles meet. First, let's find the radius of the semicircle in terms of A. Notice that the apex of the large triangle touches the arc directly above the center. So the radius equals the height of the large equilateral triangle. Now we need to find the height of an equilateral triangle with side A. Let's derive this. Consider an equilateral triangle with side length A. Let's drop a height from the apex to the base. The height lands at the midpoint of the base. This creates a right triangle on the left side. We can use the Pythagorean theorem for this right triangle. The first leg is the height, h. The second leg is half the base, over 2. And the hypotenuse is the side of the original triangle, A. So we get h squared plus a over 2 squared equals a squared. Let's expand over 2 squared. Substituting back into our equation. Subtract a squared over 4 from both sides. On the right, a squared minus a squared over 4 equals 3, a squared over 4. Taking the square root of both sides. This simplifies to square root of 3 times a, all over 2. Now we can express the radius in terms of a. Since the radius equals the height, r equals square root of 3 over 2 times a. Now let's analyze how the small triangle fits in the circle. The top right vertex of the small triangle lies on the arc. Since Q is on the circle, its distance from O must equal r. Let's find the horizontal and vertical distances from O to Q. First, how far is point P from the center O along the diameter? The large triangle's base has length A and is centered on the diameter. So P is at distance a over 2 from O. Now the small triangle is equilateral with apex at P, pointing down. Its top edge is horizontal, since the triangle is symmetric about a vertical line through P. Let's find where Q is relative to P. Consider the small triangle's geometry. From P to Q, the horizontal distance is half the base of the small triangle, B over 2. The vertical distance from P to Q equals the height of the small triangle. Using our height formula, this is square root of 3 over 2 times B. So Q's horizontal distance from O is a over 2 plus B over 2. Point Q is at horizontal distance, a plus B over 2 from O, and vertical distance, square root 3 over 2 times B. Since Q lies on the circle of radius r, we can use the Pythagorean theorem. Since Q lies on the circle of radius r, we can use the Pythagorean theorem. Substituting our expressions for the horizontal and vertical distances. And we know r equals square root of 3 over 2 times a. Let's simplify each squared term. Multiply everything by 4 to clear the denominators. Let's expand a plus b squared. Substituting back into our equation. Combining the b squared terms on the left, b squared plus 3, b squared equals 4b squared. Subtract a squared from both sides. Divide everything by 2. Rearranging with everything on one side. This is a quadratic in A. Let's find the ratio of A to B. Divide the entire equation by b squared. Since k equals a over b, this becomes k squared minus k minus 2 equals 0. This factors nicely. So k equals 2 or k equals negative 1. Since k is a ratio of lengths, it must be positive, so k equals 2. This means A equals 2b. The large triangle's side is twice the small triangle's side. Let's see what this tells us about the areas. For equilateral triangles, the area depends on the side length. The area is square root of 3/4 times side squared. So the large triangle's area is square root of 3/4 times a squared. And the small triangle's area is square root of 3/4 times b squared. Let's find the ratio of the areas. The ratio equals a squared over b squared. Since a equals 2b, a squared equals 4b squared. So the ratio is 4b squared over b squared, which equals 4. The large triangle has 4 times the area of the small triangle. Since the small triangle has area 3, the large triangle has area 4 times 3. That gives us 12. The area of the large triangle is 12 square units. And that's our answer.